Okay, now that you know how to enter transfer functions into the spreadsheet, I'm going to show you how to look at the plot and identify what the transfer function is. What I would suggest that you do to practice for the final exam is to work with somebody who will make up a transfer function, type it into the spreadsheet, and then have you identify what the transfer function is. So the first thing I'm going to do is demonstrate what it looks like when you have poles, or in other words S-terms, in the denominator. So what I'm going to do is enter this simple transfer function that you see in Mathematica over there into this. Now the way you're going to see it, let's expand the whole thing. This is if you have a whole bunch of data, you look at the little blue curve there, and these plots are called Bode plots, and they're nice smooth curves. These are difficult to read simply because they're just too curvy. So what I'm going to do is try to make it more clear and distinct. So what you want to do is you want to look at the sheet that's called the sketch of a magnitude Bode plot, which is shown here. So go to that one, and what I'm going to do is enter in this transfer function that you see over here. In this particular case, I have no zeros, so I'm going to delete the zero columns. Previous video showed you how to do that. I'm going to change the constant to a 1, and then here I only have one pole, so I'm going to get rid of these two, and the pole is at s plus 10, so I'm going to type in a 10 here, and now let's expand and take a look at the Bode plot. So all I'm trying to do right now is to help you look at this Bode plot and identify where the zeros and the poles are. The zero or a pole will result in a change in the slope. Now what you're going to be looking at is this data right here, which is called the gain in this case. That's another word for amplitude. So make sure you look at the correct graph. I'm not showing what to do with the phase in this class, just the gain. So anyway, if you look at the gain, I see one place where the slope has changed. The slope changes at 10. And if you notice that that's where the pole is, over here. The pole is at s plus 10. And the slope changes at that point. If you change this pole to, say, 1, watch what happens to the graph. Now all of a sudden, it shifted up. I'll address that later. Right now, I'm just looking for the S terms in the numerator and denominator. So what's happened is the pole is now at s plus 1, and you notice that the change in the slope occurs at the frequency of 1. So now I know that the pole is at 1. So if you make it, say, 100, I think you can imagine what's going to happen with that. Again, it shifts. Don't worry about that right now. And the break of the slope occurs at 100. So you know that it's an s plus 100 term that you just passed. The way you know that there's only one and not two of them in there is you look at the change in the slope. Okay, so the way you know it's a denominator term and not a numerator term is that the slope becomes more negative. Whenever you pass a denominator term, the slope becomes more negative. Whenever you pass a numerator term, the slope becomes more positive. Okay, let me pause for a moment, and then okay, what I did during that pause is I closed the file without saving it, and I reopened it because I want to now show what happens with zeros and poles, numerator terms and denominator terms. We'll start off with something more complex. Let me open up the Mathematica and type in what the transfer function is for this particular case. So for the one that's showing in the spreadsheet, is going to be the constant is 1. The numerator terms, there's two of them, s plus 1 plus 1, and let's make it s plus, s plus 1. We'll do another one, s plus 1 in the numerator. And in the denominator, I have a s plus 10, an s plus 100, and I've got two of those, so they're squared. So there we go. So that's what the transfer function looks like now. Okay, so I want to identify that. And so I've typed that transfer function into this graph. So let's take a look at what the graph tells me. Okay, we'll ignore the constants for right now. I just want to identify the fact that there are 2 zeros and there are 3 poles. So here's how I'm going to do it. Every time you pass a 0, you will get a change in slope. Whenever you pass a 0, the slope will become more positive. Every 0 that you pass, you will get an extra 20 on the slope. And the slope is in decibels, not regular amplitude. So you have to be able to convert to decibels. So what's happening here is the slope starts out at 0. I've not passed any S terms, and then all of a sudden here at frequency of 1, the slope becomes from 0, it becomes more positive. Because the slope has become more positive, I know that I have passed a numerator term. Now look at the slope. The slope was 0, and now the slope from this point right here up to this point, 1 decade, it's changing from 100 to 60. So that's 40 decibels over 1 decade. Every S term is going to give you a change of slope of 20. I have a change of slope of 40. That means I must have passed 2 S terms. They're both in the numerator because each one gives me a slope of 20. So 20 and 20 is 40. So that's how I know there are 2 zeros and they're both located at 1. Now if you keep going, you're looking for changes in slope. It's hard maybe to see, but there's a change in slope right here at 10. Before 10, I have a slope of 40 decibels over a decade. Once I hit or pass 10, the slope suddenly becomes 20, because if you notice from a frequency of 10, I have 60 decibels. When I get up here to 100, I've got 40. So that's a change of 20 over 1 decade. So it went from a positive 40 to a positive 20. That means it got more negative. It went down. Because the slope went down, that means I have passed a pole. That's something in the denominator. Slope went down. It's a denominator term. What is the denominator term? It's S plus 10 because the change in the slope occurred at 10. So I know that the pole is S plus 10. Did I pass 1 or did I pass 2? I only passed 1 because the slope only changed by 20. Now I keep looking for changes in slope. I see another change right here. So at this S plus 100 is another term. And it's a denominator term because if you notice the slope has become more negative again. What is the slope after 100? Well, the slope after 100 is a negative 20. Right? So it's the slope is a negative 20. It used to be a positive 20. Well, how much did it change? It changed by 40. It went down 40. That means I passed 2. You get 20 for each one. So I've passed 2 poles at S equal 100. So you can see that the S terms are one of them right here. It's a numerator. It's at S plus 1. There are 2 of them because the slope changed by 40. And then there's another one right here. It's a denominator term at S plus 10 in the denominator. It's the denominator because it became less positive. And it only changed by 20, so there's only 1. Here again, a denominator, S plus 100. There's 2 of them because the slope changed from 20 to 0 to minus 20. That gets me the S terms. Next, I'll show how to put it all together. Here is another example to try and find the transfer function. In this particular case, if you notice, the initial slope of this data on the magnitude is originally minus 20 decibels per decade, which indicates that at the very beginning you are already past a S term. That means that either it's an S plus something below 0.01, or else it's probably s plus 0. If you're concerned about exactly what that is, you'd have to collect more data, and to do that you would get a lower and lower frequency and see if it continues on the 20 decibel slope. If this shows up on an exam, what I want you to assume is that that must be an S at 0. Otherwise, I'll show you more data so that you could see that the slope does in fact change. So in this particular case, because it's beginning with the slope of 20, that means I'm already past an S term, and it'll be S plus 0 in this particular case. It's a denominator term because the slope is initially negative. There's only one term at S plus 0 because the initial slope is only 20 decibels per decade. So you can see it starts at a negative 20, and then in one decade it's down to a negative 40. That's 20 decibels in one decade. So the first term is S plus 0. It's in the denominator. The next change in slope occurs at S plus 1, and that is a numerator term because the denominator, or the slope, went from a negative number to a more positive number. In this particular case, there must be 2 zero terms because each one will increase the slope by 20. So if I pass 1 S plus 1 in the numerator, I will get a slope of minus 20 plus 20 is 0. But I have more than that, so I must have passed 2. So this is going to be an S plus 0 in the bottom and an S plus 1 squared in the top. The next change occurs right here at S plus 10, and it is a denominator term because the slope is becoming more negative. The slope changed by 20 decibels, so that means there's one of them in the denominator. The next change occurs at S plus 100. It's also a denominator term because the slope becomes more negative, and it's only one that I've passed because the slope changes by 20. So in summary, I'm going to have an S plus 0 in the denominator. I'm going to have an S plus 1 squared in the numerator. I'm going to have an S plus 10 in the denominator and an S plus 100 in the denominator. So if I slide this out of the way, you can see that that's what I have. I have 2 zeros at S plus 1, S plus 1. Here is the S plus 0, the S plus 10, and the S plus 100. So that demonstrates, well, let me show you what would happen if the 0, if you had an S plus 0 and an S plus, we'll put a 10 in here. Okay, so now what happens is this S plus 0 term right there causes it to have an initial positive slope, because at this frequency you're already past S plus 0, so it's going to have a slope, and it's because it's in the numerator, it has a positive slope, and if you notice the slope is 20 decibels per decade. So right here it goes from a negative 120 to a negative 100 in one decade, a slope of 20. So that means there's only one S plus 0 term. It changes again right here. It's hard to see, but there's a change in slope right there. That's your S plus 1. It's in the numerator because it becomes steeper. And it gains by another 20 decibels of slope. So that means that there's only the one. And then here it goes from 40 decibels of slope to 0, so you're passing 2 of them at S plus 10, and then again here's your S plus 100. If you have 3 of them, 10, 10, and 10, here's your S plus 0 in the numerator, here's your S plus 1 numerator, and then here is S plus 10 in the denominator, and it goes from a positive slope of 40 down to a negative slope of 20. So it went from a positive 40 to a negative 20. That's 3 decibels, or 3 poles in the denominator. Okay, so hopefully that tells you how to find all of these S terms.